what I would like to do now is to go through some of the points that I think are highlights from my perspectives in terms of a summary. So bringing everything together now from the statistical point of view and giving you a few hopefully helpful pointers. I decided that I would label them A to J, just that they would be remembered more easily, starting with attention to detail. And I think that cannot be really stressed enough, because when we do corpus research, we use a large number of tools, large number of corpora, and perhaps different statistical packages, and we sort of copy-paste the data and work with large data sets and so on and so forth. And it is really easy to get these very basic data operations, the low-level data operations, wrong. If you make a typo in your Excel spreadsheet, no matter how complex your data model is, be it logistic regression or any other data model, the results will be wrong just by you not seeing the problem in the elementary data set. So being able to double check, even if you are tired late at night and sort of processing the data, it might be good to return in the morning and just with fresh eyes seeing this. And very often it's not about statistics or the sort of statistical measures themselves, but about the process that could be and should be rigorous enough for us to be able to repeat and replicate what we have done. Basics first, and it's a good idea, and we've done that in this course as well, to start with some basic descriptive statistics, familiarize yourselves with the data, get the sense of the data, visualize the data, look at the data from different perspectives. Imagine your data being an object and you want to look at it from various perspectives and get a sense of what the data is telling you without jumping to conclusions, without trying to applying the statistical test as yet. Well, clarity throughout the process, clear, transparent, and well motivated. And this is especially important about the research design. And I think enough attention is not paid to research design. People are sort of trying to think, okay, what statistical test should I be using? But it all starts with your construct definition, with your implementation and operationalization of your variables. And if you are clear throughout this process, then obviously you will be much more successful. Corpus linguistics is wonderful, and I think it's the only discipline I know of that has data in its name. Right? We have corpus, and that's the sort of cornerstone of what we are doing. And obviously, as an empirical discipline, we need to pay enough attention to the data and quality of the data. We talked about the corpus sampling, representativeness, and all these topics that are of paramount importance. Effect sizes. And we talked about effect sizes. I'll mention some effect sizes in a moment as well and try to systematize the thinking about effect sizes. We mentioned R as a very commonly used effect size, the correlation measure, but there are many other effect sizes. There's the increasing trend in statistics and statistical thinking to focus more on effect sizes because they actually tell us something important about the reality, and focus less on the p-values. So more attention to effect sizes and then interpreting them in the proper context of linguistic and social theory. If you are a beginner and have just started exploring data and exploring quantitative methods, it is a good idea to follow the good practices in the field. If people have published an article, you might like to replicate their methodology, for instance, and see whether that will be applicable to your own data. So review the good practice in the field and try to follow the good examples. However, that might be also bad examples in the field. And corpus linguistics is a fairly new discipline, and people are sort of trying to apply different methodologies, different points of view. Some of them are more helpful than others, arguably. So the other thing would be also to learn critically evaluate what people have done and always ask the question, what is the motivation for this? What is the research design behind this? And do I really understand, and does the author understand, the assumptions that are being used here when we are testing what we are testing? Graphics, and I'm a visual person. I like graphics, images, metaphors, and if you are like myself, then you can probably appreciate different ways of visualizing data to identify patterns. And just with Tufty, sometimes the picture can be worth 1,000 words, and in that case, this is something that should be supported and included in our research reports. We want to highlight both similarities and differences, and too often do we focus on differences in data. We want to compare our corpus of interest with a reference corpus. We want to compare one group of speakers with another group of speakers, and so on and so forth. But the similarities are equally as important. Think of lock words, right? How many people have reported lock words in their analyses, right? There's a sort of a huge crowd of similarities that speak volume when we interpret them properly. We also have to be mindful of the interplay between statistics and linguistics. We want to provide robust statistical analysis that is grounded in linguistic and social theory. This is our training as linguists, social scientists, and educators, and all the other disciplines that we have here as our expertise. And statistics can be a useful toolbox in that. But we are aiming at providing some connections to linguistic and social theory. And the final one, jargon, and obviously, there's a lot of statistical jargon. There are equations and there are terms, and some of them can be useful, but some of them, might just muddy waters. So statistical terminology is useful, but where it helps express things clearly, but I would try to avoid unnecessary jargon, because sometimes people just hide the fact that they don't quite understand what is going on there. What I'm trying to do, for instance, in the book, and I'm not sure how successful this is going to be, well, you ultimately, if you decide to have a go at it, might decide. But what I'm doing there is using plain English in the equation, so I don't use mathematical symbolism at all. I'm using language that we speak, colloquial language, if you like, to express the basic concepts even in the equations. And when I started, I didn't know whether that would be possible. Sometimes you get a lot of complexity, but I think plain language sometimes can communicate things even clearer than statistical jargon. But terminology is always useful. So this would be my 10 basic principles, A to J, just so summing up the ideas of statistics in corpus linguistics. So this was going back to the idea of the person standing in the middle of a town and not knowing what is happening and asking passers-by for help. Can you tell me how can I get to the Globe Theatre, or something like that? And what this table does for you is it gives you several options. You ask 5 people for direction. You get different answers: straight on and right, straight on and left, right and back, and so on and so forth. Then you get the people to tell you what they think. I'm sorry, I'm in a hurry. Or they give you all sorts of things, and then you can also look at the person's profile. Right? Some of these things are uttered by a man in a Mad Hatter costume. So would you believe them? So this is just again yet another metaphor about when we get different pieces of information from different sources. We have to evaluate these sources in a rational way, in a systematic way, and decide ultimately our course of action. Right? You are standing, and this is what we do in science. You are standing somewhere, and you have to decide where to go. Ultimately, you have to go somewhere. So, based on these pieces of information, and again, you can think about how you would interpret all these conflicting pieces of information. When you think about it, you ultimately find your way to the Globe Theatre, just straight on and left, if you follow the guidance by the people that are trustworthy rather than the person in the Mad Hatter's costume and so on and so forth. And this is actually what we do in science, and now we are getting to the idea of replication and meta-analysis. Right? These people represent different articles, different studies carried out. Right? Sometimes they agree, but often they disagree. Right? Some find an effect of gender, some don't, effect of any variable that we are interested in. Replication is a situation where we have one research question and multiple data sets, multiple different data sets. And we ask the same research question and use multiple different data sets to arrive at an answer. Right? Study 1, 2, 3. These might be different authors, or one author running the same research questions in multiple different data sets. These studies will provide some answers, and ultimately, when we put these studies together, we have a meta-study, and the process of creating this meta-study is called meta-analysis. So it always starts with one single research question, right, that is being answered with multiple data sets. Very often we enter this process at this stage when we do literature review for our analysis. And there are two approaches to literature review. There's this narrative approach, and there's the usual approach in social science where people just summarize the results. But there is also this quantitative approach, and that's the approach of meta-study, where you actually put all the statistical results together and arrive at a single effect of those studies. Right? There's only one condition, and that is not always met. These studies have to report these statistical procedures properly. Right? And not in corpus linguistics, this is not always the case. So also this is an appeal to all of us, to the field as well, to report. Well, I mentioned the collocation parameter notation. There's an example. If all people report their collocation statistics in a standard way, then you can bring them together as a meta-study. If they don't, then you don't know where they are coming from. So again, we want to have some kind of standardization in the field and standard reporting. So the process of a meta-study, step by step, 3 basic steps here. You want to read around, do some Google Scholar searches, and identify the relevant studies. The relevant studies are those that answer the research question of interest. You extract the relevant pieces of information. This is called coding in meta-analysis, and I'll show you a coding sheet in a moment. And then you perform the statistical synthesis, so where you put all the results together and arrive at a sort of a combined result. Right? So it's really, conceptually, it is really, really simple, but there's a lot of hard work behind it. So you start with your searches. Let's take as an example, and I've run a real meta-study to show you how this is actually done. So I was interested in gender and pronouns. Right? Does the pronoun use differ according to gender? Do male or female speakers use more pronouns? Right? So this was my research question, and I started searching around gender and pronoun use. One thing to remember is that you want to be sure that you are getting as many studies as possible. But also the question is, where do you stop only with the studies that were published? Or do you go into student essays or theses and dissertations and so on and so forth? Because we in statistics recognize something called publication bias. I mentioned the fact that people very often start celebrating and start publishing things when they in their studies get results that have low p-values. Right? There's a clear example of publication bias, because the studies that do not find a significant effect are not published, are not reported. Right? So we have quite a systematic skew towards significant results. Statistically significant results. And sometimes this is part of the editorial practice. So sometimes you need to go to unpublished works to find that's the whole picture. Student PhD theses might be a good example, where you have multiple results and only a handful of those are statistically significant. So this is something that we call null results that are not statistically significant. The other big question is, of course, the quality of unpublished works, because the published articles go through this peer review procedure, sometimes more, sometimes less rigorous, but at least you get some feedback in the process. The unpublished studies might not be well designed, so you have to look at them critically, look at their methodologies, their assumptions, and whether they are worth it or not. Because if they represent the person in the Mad Hatter's costume, then you don't want to include them in the sample. And of course, the traditional garbage in, garbage out. If you start with garbage, there's no hope for meaningful results. Okay, this is an example of a coding sheet, and I included in the book if you want to use a similar structure. You start with some basic information about the book. Sometimes you might have multiple people doing the coding if you are part of a research team, so it is a good idea to have the coder's name there as well, because if the coding sheet includes some judgment variables, you might like to do some inter-rater agreement statistics and do part of the coding several times, or at least repeat it for inter-rater agreement statistics. It is good to note the quality of the study based on the judgment of the rater. So this might be a judgment variable straight away here, but we want to avoid low quality, low standard studies. So again, here's a study on gender differences in language, including pronouns. Then it is a good idea to describe the data set, in our case the corpus that was used, the name of the corpus, number of tokens obviously, but what is even more important is the number of cases, number of texts or speakers in the corpus, because if the statistics are done properly, they would report these and would take the individual differences and in the individual texts into account. So, for instance, there are 5,900 something male speakers and 8,353 female speakers, quite a lot. And you can also talk about representativeness of the corpus, the way we talked about it in our previous lectures. Then you might like to focus on the method. So you start with the study research question corpus, and then you focus on the method, the procedure. So which research design was followed? And we know that there are three basic options in corpus linguistics. The individual text or speaker design, which this particular study followed, but you can have also the linguistic feature or the whole corpus design. Right. Generally, those studies that follow the whole corpus design are not suitable for meta-analysis because they don't report the distribution statistics that are important for carrying out meta-analysis. Relevant variables, relevant linguistic variables and relevant explanatory variables. Here's gender, the only explanatory variable, and any other things. And finally, we want to focus on results and especially effect sizes, the effects observed. Because one of the advantage of effect sizes over p-values is that they can be compared across studies. You can't compare p-values, right? Because they depend on the sample size and they differ. They are unique to the study. Whereas the effect sizes can be compared and are indeed compared in a meta-study. So here, for example, was the effect size measured? Yes. If you say no, then again, you can't include the study in your meta-analysis. What was the effect? And you can sort of say the effect of gender on all personal pronouns. They report Cohen's D. The direction was that female speakers used more personal pronouns overall. And there was another effect on the first person pronoun specifically, and that was slightly smaller, Cohen's D 0.17, plus, again, when the same directions, and any additional statistical measures reported, such as means or standard deviations in this case. So descriptive statistics are interesting as well. You copy-paste the data into the Lancaster StatsTools Online, and this is the output. Output of a meta-study, visual output of this statistical synthesis. What you have here are the studies that were included, and ultimately I was able to include only 4 studies, right, out of all the studies that reported the effects of gender on pronoun use. Because the other studies were not suitable for that. Or they used the same data set. What is important to know is that these studies should use a different data set, right? Different corpus. So if you have 5 studies using the same methodology based on the British National Corpus, you should include only 1. Otherwise you are cheating, right? The independence of observations is important here, as in any area of statistics. Okay, what we have here is this sort of box that shows the effect, and these are the 95% confidence intervals in the graph, and you have the effect measured as Cohen's D, right, a very typical measure of effect size. So we have 0.36, then a slightly larger, 0.51, 0.59, 0.76, and we have the confidence interval for each of those. The final summary is the overall effect size. This is what we are actually after. This is the whole purpose of the meta-study, and this is given in this single graph for you as this diamond, right, that shows you also the boundaries of the 95% confidence interval. So the middle of the diamond is the mean, is 0.47, whereas it can range in the population likely from 0.32 to 0.62, right? So it gives you the boundaries of the confidence interval here for the overall Cohen's D. So what you can say is that indeed in the literature there have been studies reporting the effect of gender on pronoun use, and they all went in the same direction. They reported the preference of female speakers using the personal pronouns over male speakers, right? With the overall effect 0.47 Cohen's D. Right? So this would be a summary of this meta-analysis of these hours of data coding and combing through literature. Okay, here's a think about and discuss, but maybe we'll just think about it. Imagine that you are preparing for a half marathon and you want to evaluate the effect of the training, right? So you started your training and you want to prepare for that. Before the training, you ran 200 meters in 1 minute, and after the training, you ran 220 yards in the same amount of time, so one minute. Did the training help? Well, obviously, we need to decide whether we want to go for the metric system or whether we want to go for the imperial system and then run the conversions. And that is very much the case in statistics as well, because people very often report different types of effect sizes, R or Cohen's d or odds ratio and so on and so forth. So the first step would be to convert everything to the same unit of measurement, right, as in this case. So if we run the test here, and the answer would be, well, 220 yards is just over 200 meters. So there's 1.2 meter improvement per minute. Well, does it matter? Overall, when you think about half marathon, you gain something like 38 seconds. Again, this is where the statistical analysis ends. And then you have to decide, as a person training for half marathon and seeing the competition there in the field, whether this is worth it or not. Is it a large effect? Well, if it helps you win, then it probably is, right? If it doesn't, it's probably not worth the bother, right? So again, this is where the linguistic interpretation comes in. Is this something, and now going away from the metaphor itself, is this something that we can observe, see as a stylistic effect, for instance? Would a speaker or addressee be able to notice this? Or are these patterns that have some implications, even subconsciously? Right? So again, we will have to decide whether this and 38 seconds is our effect. The effect of training, right, would be large, medium, or small, depending on the context. So just to summarize, effect is anything observable that is of scientific interest, right? As general as this definition is. Effect size measures in corpus linguistics quantify the observed linguistic variables and the differences and changes in their frequencies. So we are observing linguistic variables usually, right? These are our effects, or changes of linguistic variables over time, or differences in frequencies of linguistic variables between two groups, right? So these are our effects. And there's a range of effect size measures, and there's an easy conversion between them. So just a few effect size measures, just to give you the sort of range of options that are available in the field, and there are many, many more. So these are the effect sizes, and I won't go into details. Some of them were covered here, like the R coefficient, Cohen's d, but there are some other variables as well. Kramer's V is an effect size, an overall effect size for chi-square test, and so on and so forth. We covered the effect sizes in terms of their association measures for collocations, and that can be also understood in terms of the sizes of the effect of the relationship between words. There's an easy conversion, and on the website you have a tool where you can type in one effect size and get all the other effect sizes. So again, you don't need to remember these equations. You don't need to even use those equations, but these are the equations that are behind the conversion. So there are some standard conversions. If you start with R, you can go back to the Cohen's d. If you start with Cohen's d, you can go to R, and you have other types of conversions, and you can basically get all different sorts of effect sizes. My favorite one is Cohen's d, and usually it is a good idea, if you are thinking about which effect size to use, to stick with Cohen's d and try to convert everything else to Cohen's d, and then run the meta-analysis on Cohen's d. That's something that can be done, but also depending on your research question. If you have lot of studies using logistic regression, you would probably stick with log odds ratio. Right? If you have these sort of grammatical studies, they would report log odds ratio. So you might like to just run your meta-analyses with log odds. Again, the million-dollar question is the interpretation of effect sizes. There are some standard textbook interpretations of different effect sizes, such as R, Cohen's D. Eta squared is an effect size used for ANOVA, where you have comparison of multiple groups. And Kramer's V is an effect size for the chi-squared test with 2 times 2 contingency table. And these are just some of the recommended results. What we ultimately have to understand is that we are dealing with a Klein, and think of Cohen's D as an example of a prototypical effect size measure. It can range from 0, which means no effect, to something large as 4, for instance, even over 4. So there's no maximum for Cohen's D. But empirically, it doesn't go very often beyond 4. Right? What we are ultimately doing is we are comparing corpora, and ideally these types of distributions, but we won't always get these types of distributions. So in this case, where there's 0 effect, these corpora would 100% overlap. Right? So these two samples would come from the same population. An example, if you want some linguistic examples for different Cohen's D measures, 0 effect or almost 0 effect would be the definite article in 2 randomly selected subcorpora of the British national corpus. Right? Well, because the subcorpora are randomly selected, there's no effect. Something like 0.7, if you look at lovely in female versus male speech, right? In our data, the British National Corpus data, women use more the word lovely than men do, and the effect would be something like 0.7. 2.6, when you look at personal pronouns in speech and writing, we talked about register variations. So this would be an example of a feature that varies across registers. Obviously, spoken language has many more pronouns than writing personal pronouns, so the effect would be something like 2.6, again, depending on the corpus. And if we want to go closer to 4, we have something like passives in academic writing versus informal speech. Right? So again, register variations. Passives are very frequent in academic writing, but very rare in spoken language. Right? So just to see all these options, and then you can decide, what is large for you, or start with the standard interpretation and think about this. My recommendation would be to keep the effect sizes of the results that you have come up with in your previous studies in a table or on a scale like this one, to be able to compare one effect size with another. Say, okay, my previous study showed this type of effect, and I was terribly pleased with that. Now I'm seeing this effect, so I'm even more pleased with that, and it's probably even stronger, even more noticeable stylistically. All right? So keeping a log of these, and based on this empirical distribution of the effect sizes, then we can ultimately decide what is a small, medium, or large effect size. Because this is actually how people decided on those cutoff points. They've run lots of social studies, but all these cutoff points are based on social studies, not linguistic studies. And there haven't been any studies empirically validating effect sizes for linguistics or corpus linguistics. So there's this wonderful area of opportunity that awaits all of us to place more effect sizes on this scale. Okay, things to remember. Statistics helps us express quantitative information with precision and rigor. And this is why we are doing what we are doing in statistics. Meta-analysis provides statistical summary of multiple studies by combining the effect sizes. And the results of the meta-analysis can be visualized as this plot that we call the forest plot. To deal with inconsistent reporting of effect sizes, we can very easily convert one into another and then run the meta-analysis. Standard effect size measures can be understood in terms of the probability of superiority, but I haven't mentioned this. There's some kind of a meta-understanding of the different probabilities behind the effect sizes. If you want to know more, you can read chapter 8 of the book. And effect size measures can be interpreted with the help of these benchmark points, which I showed you in the previous slide. And these benchmark points actually give us some kind of grounding of these statistical measures in linguistic and social reality. And this is actually ultimately what we need to do. So thank you very much for this.